Okay, this is a supplemental lecture on process evidence that is going to cover how to collect evidence by showing the commands on both Unix and Windows for evidence collection related to processes. So the first and simplest form is what I'm calling process listing snapshot. It's a snapshot because this is going to capture what's running on the machine the moment you issue this command. And some of the commands you might use, or you may possibly use a combination of, would be a full listing with PSAUX, a full listed with additional information using the -EF option, or by specifying with the -O option exactly what fields you want to see. And then, of course, we've talked about this before, the -- forced. If PS supports it, will draw a process tree. So if you were to use the PS command to collect evidence, this might be one of the lines of output you see. Now, there's a couple of things suspicious about this. First, it is using almost 100% of the CPU. And second, it is running out of temp. And on top of that, it's running out of a hidden directory .x in temp. So running somewhere where everybody has full access to write, and then trying to hide the directory that the crypto miner is running in. Now, if you want to do, and the other thing is it's running as root, which is elevated writes. So that could be another sign that something is suspicious. Now, the exact same thing in PowerShell, that is, give me a process listing snapshot, would involve using a series of PowerShell commands shown on the screen. Now, sometimes it's handy to have a process tree, which might be called an attack chain, to show how the processes were started, what processes started what. And you can get that with the -- forced option if your PS supports it. If not, you will need to install and instead use PS tree. And what's going to happen is something like this will come out. The secure shell daemon is running, so somebody secure shelled into the machine. It's running bash as the shell, and the command they're using is netcat or nc. So, that's a suspicious process. Now, in PowerShell, you can issue this series of commands and get very similar output. The next is related to your timeline. Sometimes it's handy to know when commands started. And on a Unix machine, you will get that by specifying what columns you want to see with the -O option. And S time is the main one. That's going to give you the start time. And the output will look like this. So we have a process running as root. It's running out of temp. Its name is backdoor. All that's suspicious. And it started at 2:13 a.m., middle of the night. So that is a little bit suspicious in itself. Now, in PowerShell, to do the same thing, we're going to use this PowerShell command and select, like we did with the Unix PS command, that we want to see the start time. And if we do that, it will look like this. So Explorer started at 9:02 a.m. and Chrome started at 10:15 a.m. And it gives the ID of the executable as well. Now, we've talked about deleted executables being suspicious. The easiest way to get that on a Unix machine is using LSOF and piping that output through grep, looking for the word deleted. And if you do that, you will get something that looks like this. So there's a Python script in a hidden directory in temp that is running, And then there is something running as access log. Well, access logs are not executable, so somebody's just trying to hide this to make it look like it's the Nginx web server just accessing its access log, which is not the case. On PowerShell, there is no exact equivalent. This is the closest you can get to looking for deleted executables that are running on your machine. Network connectivity by process. On a Unix machine, LSOF with the -i option, the netstack command, and the SS command, if your OS has that, are good ways to get this type of evidence, and it's going to look like this. NCAT is running from the local machine to port 80 on some machine out on the internet. So you might want to investigate that a little further. In the case of PowerShell, you're going to use PowerShell command getNet TCP connection and then pipe it through a program to pull out the information that you want. This is a rather long PowerShell command that I had to continue on another slide and yet again continue on another slide. So the network connection by process. Another thing you can use on PowerShell is task list, like shown here, to pick out a single process. Things running as privileged users. In the case of Unix, the super user or the administrator account is root. So you might just want to grep for root out of the ps command, and you might see something like this. There's a Python script running something called exploit.py. So you might want to investigate that. In the case of PowerShell and privilege escalation or execution, this is the PowerShell command that we would need to issue to get the equivalent information. Looking at command line arguments could be helpful. With the ps command, if we put cmd, or in some cases you have to put comm, it will give you output that looks like this that has the arguments. So somebody is connecting to a machine on port 4444, which is a little suspicious. In the case of PowerShell, if we want to get the command line arguments, we would need to use this PowerShell command to get those. Unix has something called zombie or orphan processes. The way we can find those is by running ps full listing AUX and grepping for a capital Z in the process state, and we would get output that might look like this. So we have a Python script running that it's a zombie, an Nginx, and an Apache. And then I didn't use grep-v to get rid of that last line. That's just me running the grep command in that pipeline. So that's how we find zombies. Now, talking about PowerShell, there is no Windows equivalent to zombie processes. In Unix, I think I've mentioned that every process is born using the fork function, which creates a new process that's a copy of the program that called fork, but then it immediately changes into whatever program you really want to run. In Unix, you're supposed to reap your children, which means after the child process goes away, you collect it or reap it and then terminate. If that process does not happen, then it becomes a zombie. Now, Windows doesn't have an equivalent, like I said there, because they don't have to reap their children. They're pretty much independent. Environment variables. There are different ways to look at environment variables that affect how things run, or possibly parameters into an executable. If your Unix supports the /proc file system, you can cat out /proc /process ID /environ, and it will give it. Or you can add the E option to the PS command. And your example evidence, or what you want to check for, is just to look through for unusual environment variables, either unusual values or possibly unusual names for the environments. In PowerShell does have the concept of environment variables, but it's a little more manual because you'll have to, for example, open the sysinternals Process Explorer, look for the process, and then click on the environment tab to get the same information. And then if you're collecting evidence, which is one of the primary concepts of this video, you would then need to copy and paste that out of the panel into a file so that you have that evidence when needed. Processes running from suspicious locations. We've already talked about that, but not exactly in this context. If you do the PS with the -O option, and we say that we want to use or look at the command, we might get something listed, and we want to look at the output for things in temp, things running out of the device directory, or things that are running out of hidden directories. Now, for PowerShell, the command or the process we would go through is we would look at the processes running on the machine, and we would check for things that were running out of temp directories, public directories, legitimate looking or legitimate directories like program data, where our other executables run from, or possibly the roaming directory. Things running out of these directories often would be suspicious. So that finishes up this lecture on evidence collection.